A liter of crude oil, the fuel that helps power the entire global economy, costs less than $1. Yet some types of printing ink can cost nearly $10,000 per liter, making them tens of thousands of times more expensive. What's interesting is that this liquid is everywhere. It's on newspapers, cardboard boxes, soda cans, snack bags, and billions of products made every single day. But what is it actually made of? And how do ordinary colored powders become the material that carries information across the entire world? Today, we're going inside a printing ink factory to find out. Let's get started. Printing ink did not begin in a factory. It began with a problem. In the year 868, Chinese printers produced the Diamond Sutra using an ink made from soot and animal glue. This technology worked very well with traditional woodblock printing, but by the 15th century, when Johannes Gutenberg developed movable metal type, he faced a major challenge. The old ink was no longer suitable. Gutenberg did not just have to invent a printing press, he also had to reinvent printing ink. After many experiments with linseed oil, resin, and other materials, he developed an oil-based ink that was thick enough and durable enough to stick to metal type. This ink played a key role in the production of the Gutenberg Bible in 1455, the first book to be mass-produced in Western history. And even after more than 500 years, the basic principle has remained almost the same. Pigment provides the color, and the vehicle carries the color. It sounds simple, but turning those two ingredients into printing ink is a far more complex process than most people realize. Not all printing inks are the same. The term printing ink covers every type of ink used in the printing industry. Within that category are dozens of different products, each designed for a specific purpose. UV ink hardens when exposed to ultraviolet light. Flexographic ink is commonly used for plastic bags and flexible packaging. InkJet ink is used in home and office printers. Each type has its own formula, printing surface, and drying speed. However, the most common type used in commercial printing is process ink, better known as CMYK ink. It consists of 4 colors: cyan, magenta, yellow, and black. This is a subtractive color system. Each layer of ink absorbs certain wavelengths of light and reflects the rest. When multiple layers are printed on top of one another, our eyes perceive different colors. Using only these 4 basic inks, printers can reproduce thousands or even millions of different shades. Black is not included simply to print black. It provides the sharpness, contrast, and fine detail that the other 3 colors cannot achieve on their own. Without it, printed images would look softer and less defined. And to see how these inks are actually made, we are going to follow a commercial ink manufacturer in Vaughan, Ontario, Canada. Every type of printing ink, whether it is used for newspapers, packaging, or banknotes, begins with 2 basic ingredients: pigment and vehicle. Pigment is the coloring agent. Unlike dyes, which dissolve in a liquid, pigments exist as extremely small solid particles that do not dissolve. Because of this, pigments are generally more resistant to fading and are less affected by light and moisture than traditional dyes. The second ingredient is the vehicle. This is usually made from vegetable oils, such as linseed oil or soybean oil, or from synthetic resins. The vehicle has 2 important jobs. First, it carries the pigment through the printing process. Second, it hardens after the ink reaches the surface, locking the pigment in place. Without a vehicle, pigment would simply remain as loose colored powder, with nothing to hold it onto the material being printed. The ratio between these 2 ingredients determines almost every important property of the ink, including its thickness, drying speed, gloss, and ability to stick to a surface. And to achieve that exact balance, the manufacturing process must be carefully controlled from the very beginning. The first step in the ink manufacturing process is preparing the vehicle. The vehicle is heated until it reaches the right consistency for mixing. Temperature directly affects the viscosity of the mixture. If it becomes too thin, the ink may run and smear during printing. If it is too thick, it becomes difficult to move through the production system. Once the vehicle reaches the required temperature, dry pigment powder is added. At this stage, the mixture already has color, but it is still far from being finished ink. The pigment particles have not been evenly dispersed, and many of them remain clumped together. If this mixture were used for printing, the result would be uneven colors and inconsistent print quality. This is where many people misunderstand how ink is made. It is not as simple as mixing colored powder with oil and calling it a day. In reality, this is only the beginning. And this is where the manufacturing process starts to become truly interesting. The raw paste from the previous step is fed into a machine called a 3-roll mill. Its design is surprisingly simple. 3 large metal rollers positioned side by side, each rotating at a different speed. The paste is forced through narrow gaps between the rollers. The intense shear forces generated during this process break apart pigment clusters, grind them down to extremely small sizes, and distribute them evenly throughout the vehicle. The result is immediately visible. The dull, uneven paste from before is transformed into a smooth, brighter, and more uniform ink. But the most important part happens at a scale that few people ever think about. The pigment particles must be controlled at the micron level, just a few thousandths of a millimeter in size. A change of only a few microns can significantly affect color density, gloss, and print consistency. For InkJet inks, the particles must be even smaller to prevent the tiny printhead nozzles from becoming clogged. Those 3 metal rollers are not simply grinding ink. They are controlling particle sizes at a scale invisible to the human eye. And that is what determines whether the color on millions of printed products remains consistent or not. After passing through the 3-roll mill, the ink must go through quality control before it can be produced on a large scale. And this is far more than a routine inspection. If the color is slightly off, a brand logo printed on millions of products may no longer look correct. If the viscosity is wrong, the ink may not perform properly on the printing press. If it dries too slowly, freshly printed sheets can smear when stacked together. Only when all specifications are met can the ink move on to full-scale production. This is also why commercial printers follow extremely strict color standards. Pantone, the world's most widely recognized color matching system, maintains thousands of standardized color formulas that ink manufacturers must reproduce accurately for each order. The red used by Coca-Cola or the yellow used by McDonald's is defined by a specific Pantone number, not by visual judgment. Once approved, the finished ink is packaged into metal containers and shipped to printing facilities. From pigment particles measured in just a few microns to colors that must match exact customer specifications, the entire process revolves around one thing: consistency. By now, we have seen how commercial printing ink is made. But there is still one question that almost everyone has asked at least once. Why is the ink inside a home printer cartridge so expensive? Part of the answer lies in technology. The other part lies in business. From a technical standpoint, InkJet ink must meet extremely demanding standards. The pigment particles have to be small enough to pass through microscopic nozzles without clogging them. Some of these nozzles are only a few dozen microns wide. Developing an ink that can consistently perform at that level requires significant research and development. But technology is only part of the story. Major manufacturers such as HP, Canon, and Epson often sell printers at very low prices, sometimes with little or no profit. The real profit comes from replacement ink cartridges. Each cartridge contains an electronic chip that allows the printer to identify genuine cartridges and, in many cases, restrict the use of third-party alternatives. This strategy is known as the razor and blades business model. Sell the razor cheaply, then make money from the blades. And that is why something that looks like colored water can end up costing tens of thousands of times more than crude oil. If InkJet ink is expensive, Banknote ink belongs to an entirely different world. Not because of its price, but because of its purpose. Regular CMYK ink is designed to produce attractive colors. Banknote ink is designed to make counterfeiting extremely difficult. A modern banknote contains multiple layers of security ink. Magnetic ink allows ATM machines to verify a bill in a fraction of a second. Fluorescent ink becomes visible only under ultraviolet light. And intaglio ink, printed under extremely high pressure, creates raised features that can be felt when you run your fingers across a genuine banknote. There is another type that is even more fascinating: optically variable ink, or OVI. Tilt a US $100 bill under a light, and the number in the lower right corner changes from gold to green. That is not an optical illusion. It is the ink itself. Behind many of these security technologies is SICPA, a Swiss company that has existed for nearly a century. It supplies security inks to more than 100 countries, yet the actual formulas behind its products are rarely disclosed. They remain among the most closely guarded trade secrets in the world. From Gutenberg's printing workshop to the 3 metal rollers inside a small factory in Ontario, and finally to the layers of security ink on the banknotes in your wallet, printing ink has never been as simple as it appears. In an increasingly digital world, printing ink is still doing things that screens cannot replace. It helps authenticate currency. It helps identify passports. And it preserves some of society's most important information in physical form. This seemingly outdated liquid continues to quietly keep the physical world running every single day. If you enjoy discovering the hidden stories behind the everyday things around us, don't forget to leave a like and subscribe to Mido Explained so you don't miss future videos.